Now, in order to plot our diagram, let's get started by actually creating our first base. So in order to do that, let's call our image fig, and this is equal to plt.figure bracket. First thing we need is num, and we'll set that as none. And then we need fig size for the dimension of our image, our graph. This should be equal to, let's say, 6,655. And then finally, what we need is dots per inch, and I'll set that at 600 or even 800. Let's say. Let's get a clear image. Now we've started our figure. Now what we need is fig dot that's actually plt dot plot, I think. Yeah, plot. So first thing we want to plot is our line, that diagonal line that goes straight through in our graph. So the x-axis of our diagonal would be an array of values from 0 to 1. And our y would also be an array of values 0 to 1. And I will say k minus. And all this does is it makes sure that the line is black. K makes sure that the line is black, and that dash means that it's a filled line, a simple dash, a simple filled line. So let's shift enter and see what that looks like. Yeah, so that is our main line. So let's plot everything else now. So what we also want is, let's start off by our actual equilibrium curve. The x coordinates are already calculated under x underscore eq, and then y coordinates are y underscore eq. And then I want this to be a red line, so I'll say r, and let's make them a normal hard filled line. So that's a dash. This time I will also label this. I'll label this as equilibrium curve. We'll also be plotting a lot of different things here, so might as well make a legend as well. So that would be plt.legend. And let's see what that looks like. Yeah, so we have our equilibrium curve, and we also have our legend right here on the top left. Yeah, so let's make the rectifying line. So the x coordinates would be REC, y coordinates would be REC, and then I want that to be a black line, and I want it to be dashed. So let's say black line would be K, and dash would be the two minus signs, and our label is rectifying section. Let's copy that to make the stripping section as well. We simply change this to str. Maybe the same thing here, str. And this turns into stripping section. Let's see those two lines. There we go. We have our stripping line and our rectifying line and our stripping line as well. Let's just make this a different type. So let's go with this. Let's see what that looks like. I don't want that to be that kind of dotted actually, so let's switch that to dash dot or colon. Oh, I feel like I used something wrong there. Yeah, I'm not supposed to use that. Let's go with that instead. All right, there we go. Yeah, that's the line I wanted. So let's draw the Q line in there as well. So I'll copy this again and paste. So we know our x coordinates are in xq, y in yq. Let's label that as Q line. And let's see what that looks like. Yeah, so we have the Q line as well. I'm just going to change the line type to a dotted line instead of that. Yeah, so that's exactly what I wanted. Now the hardest part is to plot our actual stages. So what we need to do here is also pretty much the same thing. So we copy that and paste it. And for our stages, the x-coordinate of our stages is in the matrix S, and we're only going to be using the first column. So we write that down as column, comma, 0. And our y-coordinates, in the same way, are all in the second column. So that would be S, colon, comma, 1. And yeah, I want this to be a blue line, and I want that to be a normal filled line. And I don't want any labels on it, so I'll clear that as well. And enter. And yeah, there we have it. Let's take a look at this image in new tab. So yeah, that's what our graph looks like. So we can count the number of stages right here. It's 1, 2, 3, 4, 5, 6, 7, 8. So on the 8th stage, our stage passed our Q line. So that means, the feed mole fraction. So the optimal feed location would be stage 8. And then we have 9, 10, 11, 12, 13, 14, 15. So 15 is the total number of stages that we need. And yeah, that is how we perform the McCabe-Thiele method in Python.